Hey guys, it's Miss Landry, and we are going to be talking about kinetic energy today. So let's just jump right in. If you're watching this, that means you already understand potential energy and you have mastered that. So again, just to reiterate, first law of thermodynamics, energy can't be created or destroyed. It can only be transformed. So what we're talking about today is how we transform potential energy into kinetic energy. So if you think about kinetic energy, last time we talked about potential, that was the energy stored by position. This is the energy of a mass or an object in motion. So this is similar, but this one is where the potential energy has actually been moved into motion. So for example, the ball at the top of a hill is now rolling down the hill. The unit of energy in this is joule, just like it was in potential energy. You can think of it as the ball in a bowling ball hitting pins. That's kinetic energy for sure. There's kinetic energy in atoms. There's kinetic energy of planets. So it goes all the way from the tiniest of objects to the largest of objects. So how do we calculate it? We're going to use this equation right here. Kinetic energy equals 1/2 of the mass times velocity squared. So really we're looking at two variables that affect kinetic energy, and that's going to be the mass and the velocity. So again, kinetic energy is in joules. Your mass, much like in potential energy, will be in kilograms. Always make sure to double check that. If it's in grams, you do have to adjust that. And your velocity is in meters per second. Remember, you're going to be squaring that. So let's try a problem. So we have an 8-gram bullet that was shot and it sped out of the gun at 800 meters per second. So the question is, what is the kinetic energy of this bullet? Okay, so we know that our mass is 8 grams, but remember that it has to be in kilograms. So you have to convert that, knowing that 1,000 grams is equal to 1 kilogram. Your velocity is 800 meters per second. So you're going to take half of 0.008 kilograms and multiply that by 800 squared. When you do that and you do your math, you end up with 2,560 joules, or you can convert it into kilojoules, which is what most people do, but on a test, I probably won't have you do that. And there's 1,000 joules in a kilojoule. So that's what that looks like. So here's one to try for yourself. A 6,200 kilogram African elephant that you can see in this picture here was charging at you at a speed of 10 meters per second, and you were freaking out because you took my class and you know that its kinetic energy is going to be quite high. So go ahead and calculate that, and we'll see how you do. So we are going to talk in the next video about how kinetic energy and potential energy are related. Basically, I want you to think about the fact that potential energy always leads to kinetic energy when it is released. So if you think about a balloon that's blown up, it has a lot of potential energy, but when you let go of the mouth of the balloon, right, the air shoots out of that balloon and the balloon goes flying. So that's an example of a transfer of energy from potential to kinetic. Here's two others. The hammer up here has potential energy, which we could actually calculate. And when it falls and strikes that nail, we can actually calculate how much energy it strikes the nail with. Same thing with this archer here. As he pulls back on the bow's, the string on the bow, he's holding it. The arrows get a ton of potential energy. And when he lets go, that's going to shoot that arrow out at a certain amount of kinetic energy. So we're going to learn how to do that. Always remember that the total energy of the system is equal, well, in this case, when we're looking at potential and kinetic energy, the work or the mechanical energy is always going to be equal to potential plus kinetic. And that's it for today. Hope that helped.